Hi, welcome to this video of a battery protection system that I designed and made. It's based on the ABLIC S-8254A IC. It offers charging and discharging with various different cutoff and over discharge voltage ratings. I'm using this only for discharging and not charging. It can be used for charging, but I'm using a separate module for charging, mainly because I don't like cutoff voltages for charging. Also, I would have to make a fairly bigger board to accommodate more MOSFETs to dissipate the heat. So I made two versions of it. So the first version is smaller PCB and it works absolutely fine. The only catch is, according to the manufacturer's spec sheet, that when you connect the batteries, it says sometimes the circuit will not activate. And I found to be the case nearly 100% of the time, which meant I then had to short two of the pins as per the manufacturer's spec sheet. So it says you need to short B plus to pin 2. It doesn't say in the manufacturer's spec sheet, but you can short B plus and P plus, and that has the same effect. This is actually the same with these modules that you buy on eBay. So it's the same chip. I believe they're fakes because this number on this chip doesn't match up the spec sheets of the manufacturer, and the cutoff voltage is very dodgy. I think this one is at 2.5 volts, which is very poor. Didn't like them. So these ones you have to short the pins. It doesn't say that. I think a lot of people connect the charger up to activate them, so that could be a problem if you haven't got a charger next to you. Here's another version of these boards using the fake S-254 chips. This one, I don't know what they've done to it, but when you connect the batteries up, most of the time it auto activates. So the ICs that I used on these boards has a discharge cutoff voltage of 3 volts, which is the maximum one I could find to buy. Here is the other version of the board. It has additional components here on the right hand side. This is a relay activated self reset, so whenever you connect the batteries it shorts the pins as per the manufacturer's specification, using a circuit that I designed. Basically it means as soon as you connect the batteries, within 2 seconds you get an output and you don't have to do any manual shorting yourself or apply a charge to get the power output. Some components on the rear side as well. And it's the same on this one. So you've got P plus, B plus, P minus, B minus, and the battery monitoring balance, well not balance wires, but wires that go to the batteries. This is not a balance, it's just a protection. So the first version, here it is, works. You've got power MOSFETs, I think they can do up to 3 amps, but I'm only pulling 1 amp so it doesn't get hot at all. You've got a current sense resistor here. There's the S-8254 genuine version. In the rear. Here's the one I'm actually using in my project. So there's the rear, the components on the back. And then the front, there's a relay and 5 transistors which do the delay activation. So when you apply power, there's a delay before the relay activates for about a second before it deactivates. And I've decided to add additional stuff like power indicator LED set to very low brightness and the relay activation LED. So I'm just going to connect this up. So all connected up. Here's my 4S battery pack as part of a tube amplifier project. Here's the module plugged in with the battery voltage detection wires, the minus output and the positive output. So these batteries are charged up, got a multimeter connected to the output. So at the moment all the batteries are disconnected from this using this isolation switch. So when I connect the batteries, the relay will get a power supply from the B plus rail, causing it to short the pins for a second, the pins according to the manufacturer spec sheet, to reset the circuit, and then it will disconnect the relay, and then you should see 16 or so volts out on there. So let me just turn it on. So there you go, 16 volts. So there's a power indicator, and notice the relay for the relay LED came on briefly and turned off, so you can hear it as well. I'm going to turn it off. So I'm going to turn it on. There you go. So that works. Here is the schematic for the battery protection system. There are two versions of this schematic. The first one is the standard design as per the manufacturer spec sheet. The spec sheet is here. So if we have a look at page 4 first. So page 4 contains all the screws for the different parts. So what I found was all the parts that I ordered on eBay that contained this ABLIC chip seem to be fake because I couldn't match any of the part codes. So the one I've got is AAWFT, which is this one here. It has a overcharge detection voltage of 4.25 volts, a discharge detection voltage of 3 volts. So it's the best one in terms of the combination and of stock availability. If we head over to page 19, here we have the 4S protection circuit. You can also do 3S. I've done the 4S, so the design is based on this. You have all the values. So I've used the default values and works really well. So the first PCB, the smaller PCB, is based on this circuit. The second PCB is this circuit plus a couple of relay control, a relay to control the automatic activation. So over on page 20, it mentions batteries can be connected in any order. However, there may be cases when discharging cannot be performed when the battery is connected. In this case, short the VMP pin and VDD pin, or connect the battery charger to return to normal status. So typically what you get of nearly all the battery protection circuits on eBay is it requires a charge to activate them. So I've incorporated in my second circuit the automatic activation. So let's have a look at the EasyEDA schematic. So here is the first schematic. It is the same as per the manufacturer's spec sheet. I've connected the R cell or ESL to VDD. That puts it, I believe, in 4S mode. And then the control pin goes into the negative, so the VSS here is negative. The only thing additional is the LED on the smaller schematic that I've added in just to indicate power is on. It was very low current because it's 22k resistor. So P plus and P minus are the output, and then B minus to B1, 2, 3 and B plus are the batteries. So the negative here, the first battery positive connects here, the negative connects here, the second battery and the positive, and so on. So B plus is the top of the battery, and B minus is the bottom of the 4S battery pack. So the activation is done by shorting VDD, which is the same as B plus, with VMP, which is why I have the reset net here. So down below here I've just briefly mentioned the specification. So you can see there's a 3 volt discharge detection. So here is the PCB. I could have made this PCB a bit smaller if I used smaller MOSFETs, but I struggle with soldering MOSFETs using my hand. I seem to destroy them even though I've tried grounding. These ones I wrap the wire across the pins, which seem to fix the issue. So because it's only single MOSFET for the discharge, I think the rating of this is 3 amps. So for my purpose of 1 amp, it wasn't really generating any heat. There's a current sense resistor here of 2 watts. I also noticed all the eBay ones, they use 2 resistors or a single resistor that's either half an ohm or something like that. This is 5 microohms, I think, or milliohms, sorry, 5 milliohms. So the current sense here probably is better than the ones on eBay. So let's have a look at so no components on the rear apart from the JST connectors. There's one here, another one here, and then another one here. So top side of the PCB, the bottom side of the PCB, and then here you have the 3D view. And then you can see I've added the power indicator LED here. And this is the schematic for the second circuit with the relay activation. So the first part of it is exactly the same, no different from the other schematic or from the manufacturer's schematic. And then here we have the relay activation. So it's part of a delay timer, so 5 transistors in total. So B plus, which comes from the top of the battery, because as soon as you connect the battery that will always be on. So I'm putting a diode in to prevent any reverse current. I don't think there is any, but I'm just putting it in. Doesn't really matter, it helps with the voltage drop as well. We then use that to charge this capacitor. So by charging this capacitor there is a delay on this transistor before it's turned on. So because this has a larger capacitor than the capacitor here, this transistor here turns on sooner because this charges quicker. So as soon as that turns on, so it's about a second or just less than a second, this turns on. In effect it turns on this one, which then causes this PNP power transistor to conduct, causing the relay to activate, which is basically this pin here of VCC, causing it to reset by connecting to the reset pin on the circuit. So once this is activated, by that time this capacitor is charged, causing this to turn on, followed by this, and because this turns on it drains the base current off this transistor that was already turned on, which then in turn turns these off, causing the relay to shut down. Just created a label here to provide a positive supply to reset So if we have a look at the reset net, so the reset's here, and VCC is effectively B plus on the other side of a diode. So according to the manufacturer, you take the B plus and you put it on the VMP pin. That causes the chip to reset, and then you get your battery output flowing through the MOSFET and out through P plus. So that is the activation circuit. It works really well. I used polymer capacitors here to make sure they don't change values over time, because the timings are very tight. So let's have a look at the PCB. So you can see the PCB is longer, so it's 78 millimeters longer compared to the other one. It is 58, so 20 millimeters longer. Components on both sides. So let's have a look at the photo view. Top side. There are two LEDs, power LED here and a relay LED here. Bottom side, some components here. It's quite tight, soldering everything, but it was okay. These two capacitors are the hardest to solder, or were the hardest to solder, so let's have a look. So as you can see, very compact component placement. Every component apart from the relay and the JST connectors and the headers are surface mount. The headers here are actually not electrically connected, they're just purely for mounting.